Hello everyone. Today I'll be making a wooden custom sheath for this paring knife that I made the other day. I'll be using Vectric Vcarve desktop, but the same process applies to Fusion 360 or Carbide Create. Thanks for watching. So to set up our sheet, we'll be doing a single-sided job. For this knife sheath, I measured it out and a width of 4 inches, height of 5 inches, and a thickness of 3/8 will work perfectly. What I'm going to do is take a 3/4 thick board and resaw it rough down the middle. Z0 position will be material surface and datum will be bottom left hand corner. Selecting OK. Now we have our sheet set up. So the first thing we want to do is import our image. So going up to import bitmap, trying to remember where you put the image, and then hitting open. So as you can see, this is a top-down photo, and I have a ruler in the image. This is very important because this is what will allow us to scale the photo. Start by drawing a rectangle, and you want to start on your ruler, and I'm going to go to 8 inches. Hit apply. And now I want to fine tune this rectangle. Double click on it and then drag it over so that I'm exactly 8 inches wide. The exact width doesn't matter, but what I want to do is have a known measurement that I can scale the rectangle. There we go. So looking at that, this rectangle width is now exactly 8 inches. Just have to be careful. What I kept on doing was clicking this move instead of adjust. So just make sure that you're adjusting the rectangle width and not moving it. There we go. Zooming in to double check. So that's right on 8 and right on 0. From this you can see it's important when you take your photo to be right overhead so you don't get any aspect. So now we're going to crop this bitmap. Select the rectangle, shift click your bitmap layer and come down to crop bitmap. From here, we're going to scale this photo. So select your bitmap, go over to transform object, set selected object size. Make sure link XY is checked and the width will become 8. Apply. We can delete this rectangle. And if you want to double check that your scale is correct, you can go to the measure tool and just select from one line to another, which should be 1 inch. And you can see X distance 0.97, so I'm really close. So next we're gonna trace the outline of the knife. Depending on the image, you can use the trace bitmap feature, but mine, it doesn't pick up the edges very good because I didn't have good enough contrast. If I would have used a black background, I think it would have worked a lot better. So I'm just going to manually copy it. So start by drawing a line. What you want to do is just trace the outline going into the handle area. It doesn't have to be perfect. Just want to trace as close as possible. Going all the way around. and then carrying it until it's right underneath your first line. Close that off, and here you have the outline of the knife. So this will serve as a baseline reference, and what we're going to do for the inside pocket is actually offset it to make sure that we have a little clearance when we insert the knife into the sheath. If your line's like mine and you have a few of these sharp corners, you can go to node edit mode, click it, and hit S for smooth. If you forget the shortcut, you can also right click on the node and hit smooth point. And that'll just make it a little smoother, turning a straight line into a curve. So from here, we're going to offset this. Because I know my scale isn't exactly perfect and it's just from an image, I want to give it a little wiggle room so that the knife can slide in smoothly. For me, I'm going to just offset it 1/32, and that looks like it has a nice, smooth, even offset everywhere. Close. I'm going to take this original layer and put it on its own reference layer. So knife, reference. Turn it red and make the layer not visible. So from here we're going to be using this as our new working line. The outside of the sheath, I don't want it to be too thick, otherwise it'll be cumbersome and not look right. So what I'm going to do is offset it 0.2. This is between 3/16 and 1/4 inch. And that looks right to me. For this sheath, I want to have an interlocking ledge, or I'll call them fingers. So when we make this, there'll be a left side and a right side, and I want those interlocking fingers to provide a spot to glue and lock in the outside profile. So what I'll do is offset this line half of the difference, 0.1. And you'll see when we go to toolpaths, what will happen is the left side, this will be machined down further, and on the right side, this will be machined down further, and that'll create an interlocking groove that makes glue up way easier. So next we want holes so that we can insert a pin to lock the knife in place. That way when a kid takes it out of her drawer or you're traveling, the knife doesn't accidentally slide out of the sheath. Go into hole. The first hole I'm going to make is 3/16 thick, or 3/16 diameter. Second will be 1/8. And this is just based off the pin that I'm using to lock it in. The pin is tapered, so it will seat in the 1/8 hole, which will be on the left side, and it'll slide through the 3/16 hole, which will be on the right side. And then I want it to be just in this corner so that when you put the pin through, there's a little wiggle room, but then it locks it in place. So finally, what we want to do is create the outside profile. This one is just going to act for machining and surfacing, but for the final profile, I want it to come into the handle and go up near the edge of the handle so that everything sits nice and it looks good. So what I'll do is create a copy of this and put that on its own new layer so it's easier to work with. Outside profile, I'll make this blue and I'll set it active. To make it easier to see, I'll turn off layer 1, which are these other lines that we first made. So for my profile, I want to come in till it just reaches the handle. I'll come straight over, down near the front, and then join it back up. If you're not happy with any of this. Like this one, I could have come in a little more. You can go to node editing mode and reselect it. And just click and drag until you're happy with where it sits. So something like that looks better to me. All right, finally, we'll go and trim. I have the button click rejoin trim sections automatically when form is closed. And what that will do is when I trim away this inside piece, it'll make this all one continuous vector. You can see that by selecting on it, and that way we can use it to machine. So turning back on all of our layers, here's what our reference lines look like. From here, we can turn off our bitmap layer, which is always imported to its own. And now to machine these, we want a left and right hand side. So I'm going to turn it 90 degrees, drag it down, and then mirror it about center line. You can do that by grouping these. And then when you select it, double clicking, you get the blue squares. Hold Alt, and that will snap it in at set rotations. So there's my 90 degrees. I'll click and drag it down till I'm happy with the offsets. And from there I can create the right hand version by going to mirror selected object, create a mirrored copy, flip about job center, and flip horizontal. So this will become the left side, this will become the right side, and I'll just move them down a little bit so that I have more clearance on the top. Great, so now we can go on to making our toolpaths. Okay, so before we start creating toolpaths, looking at these lines, I actually think this outer profile is extending too far. So I'm just going to trim it back and then remirror. I'll delete this one, ungroup, and then I just want to edit this path. So I'll draw a new line. This is my inside profile, so I think I'll just draw it about here. Finish. Finish. And then before I trim the original, I can see how that looks against my bitmap. So same thing, I can go to edit and rotate 90. And then just drag it down till it fits. So I can see now where the sheath is going to end, and that looks a lot better. Now that I'm happy with it, I'll turn off my bitmap layer, trim this. Double check my outside profile that it's all still one continuous line. And now I can remirror. All right, so on to toolpaths. Click this pin so that it stays open. And what we'll start with is surfacing the entire knife sheath down. So the reason we're going to surface it down is because it's cut out a 3/8 thick stock right now, and when you glue those two halves together, that would be 3/4 thick, which will just be bigger than it needs to be for this small of a knife. So instead I want to have it 1/2 inch thick overall, which would mean each side is 1/4 inch thick. So going to my pocket tool path, start depth is going to be 0, and my cut depth is going to be 1/8. My end mill is going to be an upcut 1/8. Pass depth 1/8, step over 40%, and feed rate somewhere between 80 to 100 is good for me. I want to have an offset strategy, climb cut. My pocket allowance, I want to cut it larger. So I'm going to go minus 0.125, and that's going to cut oversized to make sure that everything cleans up. I'll call this surface. Selecting the outermost toolpath, shift selecting both of these, and calculate. From here, we will tile the toolpath, and we can preview. Now stepping in, I'm going to cut the outside of this finger to create those interlocking grooves. So going to Profile Toolpath, Start Depth 0, and I want to make this one 50 thou deeper than our surfacing. So this would be 0.125 plus 50 thou, which would be 0.175. Another way you could do that is create your start depth of 0.125, and then your cut depth is how much further it's going from that start, which would be 0.05. The same edge mill, 1/8, and if you edit it, our feed rate set at 80, that's from our tool library, so I can bump that up to 100. I want to machine on the outside and 0 offset. I will call this outside finger. Repeating on the inside finger for the right hand side. Back to Profile Toolpath, start depth 0.125, cut depth 50 thou. This time the vector wants to be on the inside. And to make sure that they interlock, I don't want to cut these size on size. Instead, I want to overcut the inside. So I'm going to do that by minus 15 thou, and that's going to cut this pocket larger. Name it inside finger, calculate. From here we can preview visible toolpaths. And if you're ever unsure what depth it's actually cutting, you can hover over, and in the bottom of the screen it'll show you. So the top of the stock is 0. This pocket right now is at 1/8. This is at minus 0.175, and that is at 1/8, minus 1/8, minus 0.175. So I know when we glue these left and right hands together, this inside finger is going to snap on this machined path. Over on the 2D view, you can show your tool paths just to make sure that everything looks right. So we can see here that's cutting around the outside, and here it's cutting on the inside. You can also see that it's closer to here than halfway between, meaning that it's going to over machine that by our pocket allowance. So next we have the inside pockets. So go to your pocket tool path. And now the cut depth is a little confusing. So not only do we have to account for that initial 1/8, we also have to account for half the thickness of the knife and half the thickness of these fingers, because that is where the center line of these two halves will come together. So our cut depth is 0.125. Our knife is 0.1. So what that means is half of that thickness is 0.05 plus 0.05 plus half the thickness of these fingers. We're cutting in the depth of the fingers to be 50 thou, so half of that would be 0.025. So this inside pocket should be 0.2 so that it's center lined and even, and it gives enough room on either half for the knife. So 0.2. Now it's saying passes 2. I know that I've already cut in the first one 1/8, so I'm going to edit passes and delete that initial one. My strategy is offset climb, pocket allowance 0. We'll call this inside pocket. Calculate. It's telling me I need to select the vector, so do that. And we can preview. So that's looking good. Next we have the holes for the locking peg. I'll drill this inside one 1/8. Seeing my tool bit is 1/8, I know that I can just do a straight drilling cycle. I want to go all the way through the thickness of the material. It's only going to be 1/8 deep, the actual thickness that it's drilling through, so I don't need to use peck drilling. And I'll just call this drill 0.125. On this side, this is 3/16, and that's bigger than our tool. So instead of drilling, we want to do a pocket tool path. Cut depth is going to be, again, 0.375. Passes 3. I'm okay just doing this in one pass. I can double check my plunge rate, and if I'm not comfortable with the 20 inches per minute, I can slow that down, and I'll call this pocket 3/16. Previewing these two, that looks good. So when I glue the two halves together, I'll be able to put a pin through the big side and it'll lock in to the small. So all that's left is to do our outer profile. Profile toolpath, we know we want to cut all the way through. If you can't remember what your thickness is, you can type in Z equals, and that'll enter it. 3 passes, I don't need that, so I'm just going to go down to 2 passes. If you're not sure how to do the math, you can just select the 2 passes down here and hit set passes. Okay. I'm going to select these 2 outer blue lines. I want to machine on the outside, climb cut, 0 allowance. Depending on how you're holding down this material, you can add tabs if you're using clamps. For me, I'm going to use blue tape and CA glue so I can cut all the way through without any tabs. And I will call this outer profile. Calculate. And now preview visible toolpath. And that looks good. If you want to get rid of these waste pieces, just double click on them. So the only thing that could be a problem is this tab and this tab, but they're so small, I'll just knock it off with a chisel. The reason why those exist is because it didn't get cut by our 1/8 tool pass. So in the design, what I could have done is rounded over this so that the 1/8 tool bit would have fit right into the corner. Same thing with up here. But a little sanding will take care of that. You can double check all of your heights by hovering over to make sure that everything is correct. That looks good. So usually I like to reset the preview and watch it on slower speed. Just preview all toolpaths to make sure that nothing is missing or overcutting. Once you're happy with it, a nice thing to do is view toolpath summary. And you can get an estimate for how long the total machine time will be. So this is going to cut at 8 minutes. From there, you can save out, and seeing everything was cut with the same tool bit, you can group all visible tool paths to one file and then run. My post processor is the Onefinity. One thing that I have noticed is that it puts in a stop command every different toolpath. So oftentimes I will edit in Notepad and just delete all of the M03 lines. That way, once you hit start on the first M03, it'll pop up with your warning message to get tool speed up to speed, and then hit continue. You don't need to keep hitting continue each toolpath. It'll just run all the way through. All right, well, thank you for watching. Let's have a look at the actual cut. My CNC is zeroed out on the bottom left-hand top corner, and now I am ready to remove the probe and start the toolpath. All right, the G code is loaded, so I'm ready to turn on my spindle. I'm spinning at about 4.5 on the Makita router. Alright, now that it's done, we can pry off the outside. And before I pry off the inside, I'm just going to clean up all the edges with a chisel. And just like that, they snap together like a glove. Perfect seam. And paring knife slides right in. Now all it needs is a little sanding and some glue.